here we are still in chapter 5 funders, and we'll continue with this section, which basically essential functionality in the funders, right? So previously we have seen a lot of other sections working through with these funders, where we have seen a lot of other stuff, introduction, how to create a series, how to create different data frames. So today what we'll be seeing is some of the functionality that we can use with funders. So the first one is called reindexing. So we will see reindexing based on series. So the first thing is, let's assume we have a series like this. Let me clear this guy. So let's assume we have a series like this one, and we have its index here, DBAC, right? There is what we can do. Okay, let me see this. Let me do this. Okay, so that is what we will do, what is called reindexing. So reindexing, basically it changes the index. So here we can see it starts from D, B, A, C, right? What about if we want to reindex them so that it's put them in C order? That is what we call reindexing. So this function, basically what it does, it put these guys in particular order. So we can provide the indexing we want to put it to. So here this function, when we say this, so we can see that it actually put A. We can see A is 5, so it put A. But when we look at this here, when we put give a new index that is not existing, it will give none, which is NA, right? So that's reindexing. Yeah, so for order like series, it may be desirable to do some interpolation. So sometimes you can actually see that, okay, now this is 8, right? You have 0, 2, 4, right? But sometimes you may want to fill in some kind of, you don't want to see NA, right? So for example, in time series, as they give an example, where sometimes you say, okay, this value, if the next value is something that is known, replace it with the immediate one, because in time series, some of the values, they are similar. So for example, in time series, you are calculating some kind of phenomena within the time. So the previous value may be exactly close to this one. So you can replace this with it. So they have what is called a method called fill, that actually when you do reindexing, you can specify how you can do the fill. So when we see here, we can see that we said, okay, instead of, we can see here, we said the index here, we have only 0, 1, 0, 2, 4, right? But we say the index, it means 1 to 5, right? So we have 0 to 5, we have 6 stuff, right? Unlike we have 0 to. So the first one is 0, which is blue. Then we have 1, because we say range 0 to 5. So from 0 we have 1. So the 1 will have the value close to the previous one, which is value, right? Which is blue. So also we can see we have 2. The next one is 3. Then the 3 will have the. So this is what we call fill. So fill allow you to basically, when you do the indexing, if there is nothing you can do. So the fill is different kind of stuff. We have different kind of fill. Let's see it. We can see we have pad, propagate the last valid observation. We have backfill. We have nearest. So pad, propagate last observation forward to the next. So that is pad. We can use pad or fill, fill or whatsoever. So here it means it will use the last previous one. That is what we use. But if you use the backfill or nearest, it can do different kind of filling. You can see here, when you use backfill, use next valid observation. So instead of here, when we, let me change this guy to be maybe back fill, right? Backfill. I think I'm correct, right? Backfill. Oh, okay, this is the backfill or vfill like this. We can put it like this. Then if we use the backfill, it means here it will not use blue, it will use the purple, the next one. Yeah, can you see that? Yeah, so that's basically how this reindexing, so it works. That's reindexing in series. What about the reindexing in data frame? Let's look at how reindexing works in data frame. So this is our data frame. we have column, this guy and this column and this column, and we want to index this thing, that is we want to change the way they are. So with data frame index can alter either row or columns. So we can either alter the rows arrangement or columns, because that's in series we index only because there is no notion of row and column. You can just reindex based on the point. So let's look at how we can do with data frame indexing. So we have, this is our data frame. Right. Where the data? But this is the data frame, right? We have all this guy and this guy, and now let's reindex based on this. So we said frame dot reindex, we provide A, B, C, D, right? So we can see here we have only A, C, D, but we want to reindex the row based on this order. Now, when we run this guy, what will happen is that because we don't have B, so everything here with B will be an A, because we don't have this guy. We can also reindex column with the column keyword. So by default, it will index when you suffix like a list. It will index based on the row. But what you can do with column, then you can say, for example, I have my what I wanted reindex, that is the columns. Then I can say frame.reindex. I give the column there. This will reindex this. But remember here we have the original one where Ohio, Texas, California, we have 3 column, right? But here we are inputting still column 3, but we don't have Utah or Utah whatsoever. Then you can see this will be NA. So in a nutshell, you can do reindexing in both rows and column depending on the need. That is the reindexing. Any question concerning reindexing? Falalu, any question or you want to add something? That's how you can do the indexing, but we can also do the indexing using the another LOC or lock operator. And a lot of people prefer to use that for indexing. So what we mean by the indexing, like just to rearrange your arrangement of your data frame. So let's assume here. Now here we have a data frame. Here we have Ohio, Texas, and we want to do the indexing. What we can do is basically to say, okay, we want to reindex, change this. This is Ohio, Texas, California, but I want to change the arrangement to be Texas to be first, Ohio to be second, California to be third. That is reindexing column to change the arrangement. So how can you do that? The way you can do that is basically, all right. So how can we do that? So we can basically okay, we can do this is lock, as I said. This is the data frame lock, right? And we can say, okay, this is our A, C, D, our rows. We don't want to change it, but the column reindex it. So when we run this, the column will now be reindexed. So here we can see we have Texas. So this column will now shift here. Ohio will be second and California will be, and A, C, D, they are the way they are. What about if we change this guy to this guy, D to be here and C to be here? When we run this guy, we can see that A, D, C, it changes, right? So this way you can reindex both the rows and column in this way you want to do it. So that's the notion of idea of reindexing. You can do that with log. Yep. But what about if the new column, you have the something that is not in the data frame here like this? You can see we want to reindex, but the new column we have Utah or Utah whatsoever is not in the original one. This will not work, and what we will have at the end of the day, it will give us an error. So you need to have the existing one, or like using the this guy using reindexing without using the lock operator. Even this a column does not exist, it will create that column and populate it with NA if you are using reindex. But if you are using lock, it will not actually do that. It will tell you that doesn't exist here. So I think this is separate so that you will not incidentally do something. That is about that. The next thing here we're going to discuss is dropping entries from an axis. So you may have a data frame and you want to drop some part of the data frame. So for example, here we have a series here. This is a series we created. And now maybe we want to drop the number one number that is drop. So you can use the object, call the object and use the word called drop, and now specify the index. So here we said drop C. Now this value will be dropped. So we don't have that anymore. So we have this, right? So this is drop. We can also drop not only one, but a couple of these things. You can provide them as as a list. So you can see here we can drop D and C, and that will drop on D and C. That is dropping in a series. So what you should know is that dropping, these operations differs if it is a series or data frame. Remember, in data frame, in Pandas, we are having two notions in Pandas: series or data frame. Series or data frame. And what you can do in each of these may differ along the one. So always look at what are you going to do. So how can you do dropping in data frame? Let's look at, this is a data frame and we want to do the dropping more or less like the way we had. We can do this given the sequence. So we want to drop these two columns. We use the drop, and this will drop these two columns. And now we will have, this one differs from what we call from series. In series, you remember we just provide this, right? And it will drop everything that is included. But in data frame, remember, we have rows and column, right? So when you provide this, the first thing will drop the rows, right? We will not drop any column. So it dropped Colorado and Ohio. But what about if we want to drop along the column? We can do that by passing the axis. So let's look at this. You can drop values from the column by passing axis equals to 1 or axis equals to column. So you can drop by column by passing axis equals 1. So let's look at this guy. When we say this will drop actually 2. So here we can see we drop 2. What about someone may say, okay, let me not just provide this axis. We say this, and now try this guy. So when we do this, so when you see this guy is going like taking the time, something is happening. So yeah, you can see it will give you, yeah. So what you need to do is you need to specify the axis if you are dropping a column. So that's the notion of, you can see it differs from data frame and yeah. But column drop with a sequence or level will drop from the row level. Can you see that? Column drop with a sequence, if you provide a sequence, will drop the level row, right, as is 0. But if you want to drop columns, you need to specify this. But even if you want to drop series of columns, you can provide them as a series, but you must provide that you are dropping columns. Or like if you are dropping rows, by default, it is dropping rows, so you don't need to do that. So here you are dropping this guy. So the other way you can see here, these drop functions and other related functions, they do what is called in place. So what this means is that if you look at this guy, I drop this guy, right? This is not in place. I must assign my result. For example, A equals to this guy. Oh, okay, let me show you this, what I mean. So you can see here, I drop 2, 4, right? Yeah, I drop 2, 4. I have only 1 and 3, right? But what about if I call my data again? Now, you remember I dropped them here, right? So when I call my data, will I see still 1 and 3, or I will see the 4 column? Who can give us an answer? When I call my data, now here I drop them, what will happen? Daradin, what will happen?
The column has already been dropped.
Okay, so let's see. So Daradin said that here the column has already been dropped. So let's look at it if we call the data. No, Daradin, you are Kai missing. So the issue here is that this function, drop function, For you to do that, you must assign it the result to another variable. For example, you can say new data is equals to this. So when you say this guy, new data, so this new data is now a new data that has a drop function, that had the drop functionality. So when I call this new data, I will have something like this. So when I call this new data, can you see I have this? But if you don't want to do this assignment, you can do what is called in place. So here you can see, I can say, okay, this is my data. Oh, no, let me not tampering in data. So let me delete this guy. Let me delete this guy. No. Okay, yeah, let me, okay. So let me go back to my data where, yeah, this is the data where I define the data. So this is my data.
I think the data is intact.
Okay, I modify only the new data, right? Namanta.
Yes, it's intact.
Yeah, I forgot. I only modified the only new data. Yeah, so let me, oh, this guy is taking place. Okay, so what we are saying here is that, yeah, okay. So what I'm saying is that that will not work, but if you want to modify your object, no, here I have something, another object here that I don't have the object. So maybe let me call it data. Data. Oh, what is happening? My computer is, something is wrong. Okay. Okay, this is our data, right? So now when we want to do changing in place so that we drop, so what we can do, we have an argument called in place. So we can set in place is equals to true. So now here, when I said, okay, data dot drop, but in place equals to true. This means that when I call data, we'll have the, what this?
We don't have C.
Oh, okay, we have one. Okay. So yeah. What's happening? Okay, so let's look at something here. I'm calling the data frame. Let me use this guy. Yeah, okay. So that I see the problem. So here we have an object. We have an object here. The issue here, we didn't specify the axis. So let me show an example here. So here we have a series here. You can see the series. Oh. Okay, so here is a series, right? In this series here, what we can see that when we do a drop, for example, I say drop. When I say, for example, let me do this, object the drop, something like that, right? And I say what, drop C, right? No, I say drop C, and I have this. So what this means is that I'm trying to drop C, but after I drop C, I now call the same object. This means that after I drop C, when I call the object, the C is still there, right? It does not actually replace. So for me to do that, what I can do is I create a new object. right? When I create a new object, so I can call a new object here, sky. I can call a new object here. Yeah, and you can see the C has dropped. But if you don't want to do this, like to assign the new, you can do what is called implex, drop implex. So here we can have our object here, object, and we say, okay, drop C, but what we want to drop the C is implex. So when we call this, we do the drop here. The moment we call, it will automatically drop D using this stuff. So when we call this, we can see, yeah, you can see now it drops. So the issue here, the previous one, the issue that we didn't do is that, remember, if you are using data frame, so here you must specify the axis you are dropping. So if you want to do a data frame, the same thing, you have the implex, the drop, you must specify the axis you want to. That is only different. So here, that is what we show. So that is what we have seen now, dropping. The next thing we will see is indexing, slicing, and filtering. Now, how can we index our data frame? How can we do selection, and how can we do filtering? So let's quickly go through that. But remember, I said if we are talking about pandas, we always look at the functions and stuff that relate to series. Then we go and see some stuff that relate to data frame. Now let's start looking at the a series. So this is a series object. We can see this series basically had these values, right? Now, how can we take a value from this only one, maybe one and only, right? We can use index value. So we can say this index V, it can do this, then it can give me this value, right? This is called index, what do we call selection, right? We do this. And what about using this one, using integer? So we can do, for a series, we can do two things. You can use index value. What is the index value for this? You can take this value. You can also use integer position. So because this is 0 position, this is 1, this means that when I use 1, it will give, you can see all these two give me 1, 1, right? So for a series, you can actually select one values, index a value using either index value, this is index value, or using integer, right? You can do that also here. This is slicing. We can use this guy. This will give us values from 2 to 4, right? So you can see here, it gives us C and D. What this means is that C and D, you can see this is 0, 1, 2 to 4. You can see it's 2 to 4. It gives me C and D. The only difference here, remember, in Python, the last index is not included, right? But in Pandas, the last is included. Pandas slice. Yeah, inclusive, right? Inclusive. Yep. So something like this. How can I get to inclusive go? So what I'm trying to say is that you remember in Python, when you want to do slicing, the last one is not right. So, but in Pandas, this is something you should know. In Pandas, it do that. So you can see that. So you can also, you can see here, we want to use this, taking using the index. So here you can see, look at this guy. We are providing a list inside this object. We say, okay, A, B, D. So let's see what will happen. Can you see it gives us BAD, right? It gives us this guy. Remember, who can tell us now what will happen now if I use only, I supply not a list, but I supply this into this? What will happen? What is the difference? Who can tell us? Who can tell us? Abdul Awal Palalu Saada Zaradin Abdullahi. Who can tell us?
I think you will get an error.
Okay, let's run and see. So you can get an error. Can you see that? So what we are saying, if you want to index, you want to index this guy, what you need to put is you submit the list. You submit the list, right? So that's how you can do it. So that is basically how we can slice and index a series. Yeah. Any question? So to recap, given a series, you can index it in two ways. You can give the index value. So for example, here B, we can index it, or you can give the integer, right? Given this, right? But if you are using yeah, all right. One thing also we should note. Okay, now can you see here? I'm indexing, but I only give I use only one value here. I use Bonsaka Shaakaba. So who can tell us the difference now? This and the only one, the single one. Who can tell us the difference? Can this give also an error or what?
I think it will work.
So, but why be a chunk that A1 be? So we'll see the issue. So here, what is happening? When you use this, it will return a series. But when you use this, it will just return a single number. When you use this, it just return an integer, just the object, not the series. You can see it return 1. That is this position. But if you use this, then it return a series. So I think I explain it later. Yeah. So let's continue. But now we have seen that you can do selections and indexing in Pandas, but you can also use preferred way using way for selection using lock and iLock. This is the preferred way to use selection. Now we have seen that this guy give us the value, give us 1. So you can use lock, this lock, which is preferred way. If you are using the Python, you see them in a lot, they are using lock. So here you are saying lock, use this. So you can see access a single level given this or whatsoever. So let's run this guy. So you can see this guy, what it gives us is basically give us there's something, but here it gives us an object. If you want us to give this series, we can use this. Yeah, can you see that it returns that? So that is lock. You can use lock. We can also use lock instead for the previous one where we just use this guy. Use this approach. We can use this lock again. So yeah, instead of for us to use this, we can use this. Can you see that? But why do we use this? There are advantage and disadvantage of using that. We will see that the explain later. So that's we can use lock here to actually index. So the reason to prefer lock is because of the different treatment integers. So let's look at what is happening and the reason why to prefer the lock. So here I create 2 objects, which the first object is series, right? The second one, so for the object 1, here I say object 1. You can see it gives me a single number as I explained. So when we look at the object 1, its type is basically a single an array integer number, numpy integer number, right? It's just integer number. But when I use this guy, using these 2 double braces, and when I get the type, it gives me slice, right? Pandas series. I mean, yeah, it gives me series. So this is what I explained previously. But let's see our object 2. This is my object 2. And so the difference between object 1, I want to show the example. So here I have object 1. Yeah, so you can see the object one here, the index is integers, right? 2401. And the object two, the index are what? Not integers, right? So let's look at what will happen now. In index one, in object one, when we try to do, say, object 0, 1, 2, let me take this guy. Okay, for object one, because it is index is integer, when we try to get some series, we say, okay, 0, 1, 2. Let's look at what will happen. Okay, before it comes, what do you think this one? So here is our object one. This is the index. And now when we call this 0, 1, 2, what it will give us is this. It will first put the 0. Can you see this guy? It put it, the 1, it takes this guy to be the second. Yeah, so this is how we do the selection. Now, what about in object 2? In object 2, when we have this, we say, okay, object 2, 0, 1, 2. Let's look at what will happen. So in object 2, you can see that we have A, B, C, right? A, B, C, which is 1, 2, 3. So now when we say object 2, 0, 1, 2, you can see that it's already, it does not care about anything, because here will not change anything, because this is A. Okay, let me see a beta example. Maybe in the next I have a beta example, I think. So yeah, so you can see here, because this index is not integer, we can see that it just doesn't change anything. So with log expression will fail when the index does not contain integers. So let's look at what will happen. Yeah, so this is for the object one, where the index are integers. Here, when we use the log method, meaning that we want to do this, this is what will happen. So you can see this, right? But when we use this log on object 2 with log, what will happen? It still goes the same way. But when we use object 2 with these integers, so you can see here, when we use object 2 with 0, 1, 2, everything goes fine. But when we use, because the object 2 has index which has no integers, so when you use log and you use 0, 1, 2, this will actually give us an error, because the index is not integer based. So the solution for that is using another thing which is called ilog. We solve that problem. So here, for example, we have our object one, this, and we can use ilog. So ilog can work in any case. So since log operator index exclusively with levels, there is also ilog operator that index exclusively with integers. So if we have an integer, we can use this function. So you can see here we have that. And now here we can use the ilog also on the object 2, which has this non-index integer base. So this is basically what ilog and log operations method works on. So you can use this also, the log, you can use them to do the slicing as well. You can see you use log and you provide what you want to slice from B to C, right? So that's basically the slicing. So that is indexing and slicing on what we call a series. Let's look at indexing on data frame. Now, let's assume we have a data frame here. This is our data frame. And now we want to take only one column. What will happen? When we use this guy, this will take only this column. So we have this data and we provide this, it will take only this column. So when we take a single column, it becomes what? A series, right? Yes, it becomes a series because this is a series. So you can see, we can say type, and we put this guy inside. Yep. Yeah. Type this guy. Then we can see which is a series. Yeah, you can see this is a Pandas series, right? So what this is telling us is that when we have a data frame and we select a single column, then this returns a series. Now, what about, can we select two columns? Yes, of course, we can select two columns given the name of the column, and we provide them in a form of list. So here, because it's single object, it's not a list. So here we can see we provide them. So yeah, so that's how you can actually index, select a column or in data frame. Okay, so what about this? Now, assume here I want to select so you can see here what we do is basically you can see here we basically do selections of columns, single column. We have selection of two columns, right? Now, what about if I want to do selection based on rows? You want to select rows. Remember, our data is data frame, right? Now, what we can do is we can pass this a kind of slicing. So when I pass a single slicing, start from the beginning to 2, it means here it will start from the rows, the beginning of the row, and stop at 2. So here you can see here we have 0, 1, and 2. It will not do the 2 here. This is a slicing, not the one we have seen here previously. So this is how you can slice the row. Yeah, so that's basically some of the operations with the data frame. We can also do these operations using lock and ilock as well on the data frame, as we have seen them in the series. So like series, data frame has special operators lock. We saw series, right? So it's basically the same lock and ilock for level-based index and integer-based index. So level-based index, we use the lock, and integer-based index, we use the ilock. So let's look at them. So here we have our data frame, selecting a single row and multiple columns. So how can we do that? So here you can see I say data, the lock. What we mean by lock is level based. So what we mean by level, you provide the level, we say Colorado, you can see Colorado, the row, and now you put comma, this will give you the column. So when we run this, this will give us a single row, which is this, but 2 and 3, the value, the column is 2 and 3, that is only 2 and 3, which is 9. Is this 9? Colorado, 5 and 3, 5 and 6, right? So this is how we can do, but we can select, yeah, here you can see we use the level base, that is you provide, okay, you provide the level, which is Colorado, and columns, the 2. But if you want to use the not level base, you want to use integer base, you can use ilock. So in the ilock, you say, okay, row 2, which is 1, row 2, row this 1, 2, whatsoever, and you provide the columns you want. So here you can use, we use ilock, but here we use lock. So this is what we call level base. And yeah, so you can see here we said, what do we want? So what we want is basically, if we look at it, is that we want to two, right, which is this 0, 1, 2, and we want column what? Column 3, 4, 0, 1. What is column 3, 0, 1? So this is 0, column 1, column 2, column 3. So the first 3 is this guy, which is this. You remember we are slicing this row, which is 2, 0, 1, 2, right? Which is 2, and slice the column, put the 3, so you can see 11, which is 0, which is 8, and 1, which is 9. So this is basically how we can do the, more or less the way we saw with our Python stuff. Yeah. Right. So what about if you give a single number? So we use ilog, we just say 2. It will just take the whole rows, which is eta, right? We didn't specify the column. We said just this row, it will just specify the row. So when you give a single integer, it will just take the row. But when you want to take some columns, you can provide the columns you want. So what about taking multiple rows and multiple columns? So for example, I want to take this row, and now this column and this column. So this is how we can do it. We use the ilog, and we pass a list for the rows and the list for the columns, right? So here, when we run this guy, who can tell us what will be the output of this? What will be the output of this? Noor, tell us the output of this. Zaradin. Okay, so when we run this guy, we can see that it gives us something in row 1, which is cholera, because this is 0, this is 1, and this is 2. And the column we want is 3, which is this guy. We'll put this guy first because this is row 1, right? This is row 2, this is row 3, 0, 1, 2, 3. So they arrange this. So this is how you can select multiple row and column. What about slicing data frame? We know what is slicer, right? Slicing means taking some part as well. So let's look at this guy. Right. So yeah, let's look at our data frame as well. Again, this is our data frame. Here we can see we use ilog to do other stuff, but we can also use the log, which you use level based. So here you can see we're gonna use log. We said, okay, this give us the whole row, right? The whole row from the beginning to eta, and column. So we can see here, this means from the beginning. What is beginning? Ohio to Utah. Can you see that? That is slicing from Ohio to Utah, but only one column, 2, 1, 5, 9. So you can see that, right? This they looks more or less that the same how you can do that, but the only way is through practice. But now it's just for us to understand the concept. When we see what we are doing, we understand. So this is, we internalize this through the practice, and we'll see how we can practice. Yeah, so that is about how we can do indexing and slicing. That there is what they discuss, which is called integer indexing pitfalls. Yeah, so let's look at what they mean. So here, this is a Python list. You can see if I want to take the first element, I would take this guy, right? I can see this. But what if I want to take the last element? I would say the minus, right? So this is Python way for slicing, I mean, taking indexing an object, right? But what about in series? Can that work? So let's look at it. So in series here, we create an object here, series. And now when I create this object series, now I use this guy, series 1. Yeah, of course, it gives me the first one, right? But what about this one? When I use series -1, right? When I use series -1. So you can see here, when I use series 1, it gives me what? The index here, because 1, it gives me here. But here, when I use series -1, it will give me an error, because there is no notion of that we use in Python. So you cannot do this. So that's the problem, what they call, they try to do, they call integer indexing pitfalls. Yeah, integer indexing pitfall. So one may think that this may literally work just same we use in Python, but that's not correct. So in this case, Pandas could fall back on integer indexing, but it is difficult to specify what is this. So let's look at what we can do to solve this problem. So if you have not integer as your index, but you have what do you call the levels? These are levels. Let's look at if it will work. So here, remember the same thing, right? 0, 1, 2. But index the one and she we use A, B, C. But the problem here, the index we have is is 0, 1, 2, which is integers. So in this case here, we have the same thing, but the index is level. So let's look at whether this guy will work. You can see this guy, when we say -1, it gives me the last one. It means there is no, yeah. So the pandas, actually what it is confused when you use it. Pandas could fall back on integer, but it is difficult to do in general without introducing something. Yeah, so this is difficult to do that. So we should know if we are trying to do that. So if you have an axis indexing containing integer, data selection will always be labeled. So what the only solution, just always use level oriented. That is, for example, just use ilog and stuff like that. You will have the safer solution. But when you try to use this approach, integer indexing, you will have you may fall into the trap. So always safest way, if you want to do this, use ilog or log whatsoever. This will give you the perfect result. Can you see that it index? Yeah. So yeah. So in the other, slicing with integer is always integer oriented. This is what we discussed. Yeah. So that's about indexing and slicing. So let's quickly move into arithmetic and alignment. So this is one of the important features in Pandas, that it can do arithmetic and it can align many things. So let's assume here we have series 2 theories. We have series 1 and I have series 2. The only difference between these two series is that this has A, C, D, E, right? A, C, D, E. But what about this one? It has A, C, E, F, G, right? Meaning some stuff are here, like D is here, but it's not here, right? G is here, but it's not here, right? Now, what will happen now if I try to say S2 plus S1? Can Pandas use its head to find, okay, this is the index A, and add the index A plus index A, add the index C plus index C, add the index E, the E. When it comes to D, okay, D here is 3.5, but a number D, what will happen? So Pandas uses its sense to try to align this. You don't need to do, okay, this is this corresponding A. Pandas will automatically match the index. That is what we call alignment, data alignment, right? So let's look at what will happen when we do that. X1 plus X2. So you can see A. The first thing you can see, A is minus 2.1, right? But here A is 7.3. 1 num plus 1 num will give me 5.1, right? So Pandas will add them, right? But when Pandas comes to here we have a D 3.54. Then it comes here, try to search for the index D. Babushi, what will Pandas is that it will just put NA. So when something is available in one what do you call series and not available, Pandas will just put NA. The internal data alignment introduces missing value in the level location that does not overlap. Missing value will often propagate in further arithmetic operations. So Pandas will just put NA if there is no overlap. Any question before we proceed? So this is what we have seen is data alignment on series. Remember, we will always want to see data. Pandas has stuff you can do either on the series or on a data frame. So let's look at it on data frame. So we have now seen on the series, this is a data frame, and I have a DF1, right? And now I have a DF2. What is the difference between the two? So here I have B, C, D, but here I have B, D, E. The same issue with series, Pandas will do automatic data alignment. Now let me do this. So you can see Pandas put them, we have B, we have C, we have D, we have E. So here you can see B, C, D, B, D, E. It add another one. So here, because E is available in DF2, but E is not available here, Pandas will automatically put it E, but it will automatically put NA because it's not available, right? So also along the row, if we look at them here, we have Ohio, Texas, Colorado, but here we have Utah, which is not available here, right? So what will happen here is that if we come to B, okay, we have Colorado here, and we don't have Colorado here. So everything will be NA. Saboda ai babu shi a wannan, right? Will be NA. So yeah, and also here you can see we have C. And bamu the C, right? Here we have C, here we don't have C, and now it will populate everything with NA. So this is still the something that the single idea is if there is no corresponding in one of the items, it will just put NA, either in column or in row. What is in column? Here you can see we have C in this one, but Anam Babu C. Then it will create the column, but it will populate it with all NA. Here you can see we have a row called Colorado, but in this one we don't have, it will create the column row in the new, but it will populate it with NA. That is the main idea. Any question before we go on? Any question? Okay, so if you have no question, let's move on. Let's see, we finish the pandas here today, and tomorrow we can continue. So right, so let's look at another example. If you add data frame object with no columns or labels in common, the result will all be null, which we have seen. So here I have two data frame, df1 and df2. We can see here we have A, we have B, nothing in common, right? So when I do the subtraction, df1 minus df2, I will just have NAs because there is nothing in common, right? So this is what it means. You can do some mathematical operations using pandas. It take care of whatsoever you have. But sometimes you may need to use field values. So sometimes you don't need to use NA. If there is no particular value, you may want to say, okay, use 0 instead. Don't put NA. Let's look at what will happen. So let's assume here we have a data frame, again, df1, and I have another data frame, df2, right? Now you can see here, we have A, B, C, D, right? So here I have A, B, C, D, E, right? So here that we don't have E. When we do this addition, what will happen is that we will have a new column called E, but everything will be NA, right? But you may decide, no, don't put NA, just put 0. So when we do that, you can use what we call fill value. Fill value, we can say. So here we can use add, this plus this is that, but we can use a method called add. Instead of this, we can say df1 dot add df2, meaning these two operations are still the same. Even at the background, the addition is translated to this. So here we are doing the addition, but we say fill value to 0. So when we do this, we see that the remaining one, it will not use the NA, but we can see here E is 4 N 1490, right? So it will put them here. That is the other one that is not available in the in this one, in df1, it assumes everything is 0 here. It assumes everything in the E here is 0. That is why you say this argument means fill value is 0. So if we look at this, you can see if we look at add method, we have what we call fill value. Fill value. Can you see the argument fill value, which is basically we can a float number. So here you can see, yeah. So that's it. Any question before we move on? Okay, so they have they also discuss some stuff like counterpart operations. So here, for example, when I have 1 over data frame 1, so assume I have data frame, I say 1 over data frame 1. There is pandas has irrelevant functions which basically do the opposite. That is, it do okay, let me run this guy again. Yeah, so instead for you to say 1 over df1, you can use df1 r div1. So this will actually do something like this. So, or if you have 2 divided by df1, so pandas has some functions that do this kind of opposite direction. Instead for you to say 2 divided by df, then you can say df1 r d div2, means it will say 2 divided by df1. So this is something that you should know when you see it. Maybe in the, you should know what they mean. They have r add, r sub, they all started with r. You don't need to remember them, but you should know what they mean. So this is what they mean. They do the sum stuff. All right, operation between data frame and series. So now we have seen a lot of other stuff. Let's look at other operation between the data frame and series. So as with the NumPy arrays of different dimension, arithmetic between data frame and series is also defined. So we have different kind of arithmetic operation that we can do between these two. For example, in array, we know that you can use, we use NumPy array of different dimension, and for n dimension or for one dimension, we can use additional subtraction. So also between data frame and series, you can do operations. So let's look at an example. Here you can see I have array, right? This is an array, and here this is a motivation of using array. You can see here an array of dimension 0, and here I have array of dimension 3, right? Now, can I say array this one, which is this, minus this one, which is this? What will happen? This is array 0, which will give us this. This is array this, which give us this. So what we are saying is that this one, that is 1 now, minus 1 now. What will happen? Let's look at what will happen. We want to introduce the idea of what is called broadcasting. So what is happening is that this guy will take each row and subtract with this one. So here we can see 0 minus 0 is 0, right? 1 minus 1, it gives me 0. 2 minus 2, it gives me 0. 3 minus 3, it gives me 0, right? So I need one. Then one subtraction will not do only on one row. In Canada, 1 million row, it will take each row and subtract. So we can see here 4 minus 0 is 4, 5 minus 1 is 4, 6 minus 2 is 4, 7 minus 3 is 4. This is what we call broadcasting. If you try to do some operation from higher dimension to lower dimension, then that lower dimension operation will act on every dimension on the higher dimension. I don't know if we understand broadcasting. Any question on this broadcasting issue? Because this is important idea. Any question? Any question? Okay.
Awesome.
Yeah, okay. So this is broadcasting. I believe we all know the idea, so maybe that's why it's silent. They discuss the detail about broadcasting in the advanced NumPy chapter in the book. We'll see it later. Yeah, so let's look at another operation. So now here we see the operation between NumPy array, right? Array. Let's look at the operation between Pandas, data frame, and series. We just give an analogy on data frame. So let's on array, let's look at it. So this is a data frame, this is a series. Now, how can we do operation between data frame and series? Can we say there's something like data frame minus series? This means that it will take everything here minus the series. It will take this minus this series. It will take this minus this series. This is what we call broadcasting. So let's look at this guy. So look at it. So here we can see we have the series is this. So we can say 0 minus 0, it will give 0. 0 minus 0, it gives us 0. 1 minus 0, it give me 0, right? 2 minus 1, 2, it give me 0. So you can see we finish with this row, right? Then you take this again to the second row. You take this to this one. You take this and this. So that's what we call. So if you look at it, the second one, we say 3 minus 0, it will give me 3, right? 4 minus 1, it will give me 3. Can you see that? 5 minus 2, it will give me 3. This is what we call broadcasting. When you are using different shape, the lower shape will be broadcasted to the higher shape. Any question? Okay, that's about the indexing. Let's look at the function application mapping. So let's look at mapping, function application mapping, such as apply. So this is a data frame. We know NumPy on function. We discussed NumPy. We have what is called on functions in NumPy, such as absolute, which will map, which are functions that will act on everything here. So we can see here we have a data frame, we have B, D, E, right? Now, when I call this absolute value on this data frame, everything will, every object here, every point will get the absolute value. You can see here it's negative this, but when we call absolute on the data frame, every point will take, this is what we call element-wise operation. So you can see this is absolute, right? So it will take everything and find the absolute value. So do we have that kind of function in Pandas? Yes, we have that kind of function, such as apply. Let's look at what do I mean by that. So let me show an example. You can see here I have a data frame. Now I want to sum everything here. That is, sum the column or sum the row. We can use what is called apply function and put some method that will apply on the column or on the row. Now here I will use sum, and it will sum every column. So let me use this. So here you can see my data frame. I say apply sum. What I'm saying is apply this function sum on everything. So you can see here what is this, is that this sum operation is now applied to either row or column. Who can tell us what happened here? We said frame dot apply. This is what I'm trying to give us here. You can see here we have a function called absolute, which we call an data frame, but it takes the absolute value of every object. Now we have some other function in Pandas that can actually do some kind of reduction or whatsoever. Now this is our frame. We said apply. We call a function or a method called sum. It will take the sum of object we specify. We can specify whether we want to take the sum by column or the row, but by default the axis is 0. When we say the axis is 0, it means apply the function to each column. So here it means it applying this. So when we sum this guy, this plus this plus this, what will it give us? It will actually who can sum this guy and this guy and this guy? So here, this is it. If we by default apply 0, we have 0. If we come here, apply, you can see it here. You can see, yeah, we have the argument 0 index, apply function to columns. If we provide 1 to row. So here by default the axis is 0. It means it will apply to column. So if we run this will sum these values. But if we said, okay, no, we want to actually this to apply to, you can see that when you specify, you said no, when we supply 1 or columns, the function will apply to rows. So if we run this will sum everything, but according to the rows. So yeah, so you can see here. No, this is still the same thing, because if you allow it by default, it's used 0, but you can put index, is still meaning the same thing. So 0 or index, it will apply the function to each column. Yeah, so it apply to the function to each column. We'll add this and this and this. So it will find the sum to each column. That is this and this. So this is the result here. This plus this plus this is the value. This plus this plus this is the value. This plus this plus this, it gives us this value. So that's what this apply means. Then we have what you call the next one, which is sorting or ranking. Sort method. We basically know what sort means, right? So for example, here we have a series here, and we want to sort because we have this A, B, C is not in the same order, right? We can call a method called sort index, which basically sort our index. So when we run this guy, you can see it sort the index A, B, C, D, right? This is set index. That is a series, sorting a series. But we can also set a data frame. So we have a data frame here. We can see here, but when we call data frame the sort index, what will happen? Let's look at it. you can see here, it sort the index, 1 become the top, 3 become, but it does not sort the column, right? The data frame DAB is still there. Now, so by default, when you call sort index on data frame, it will sort the row. But when we want to sort the column, you provide, okay, index 1. When you say index 1, it now sort the column. So let's look at what will happen. You can see it does not sort the rows, it is sort the column, Y, A, B, C, D. So this means it will. But you can actually also, you can see here, it's sort in ascending order, in increasing, right? We can set in descending order by providing this argument. So here we can do the descending. You can see D, C, B, A in descending, right? Yeah, but you can also send arrange by sorting by the values, sort by values. So let's run this guy. What we mean by sorting by values is that it will sort, it does not set the index here. Can you see this? It does not sort index, but what it does is sort by values. It sort from the smallest to increasing it. So that's what we call sort by value. Remember, this is sort index. It will sort by index, whether when we call this guy sort index, it sort the index based on 1, 3. Can you see that based on the, but when we sort by value, it will sort by values according to this. So there, I know this is too much, but just for us to get to understand what this function, you don't need to memorize or put them, but know what they are doing. When we come to data analysis, we will understand, take them. So any missing value assessed. So when you are doing sorting, if you have a missing value, it will just be at the end. So let's look at this sort that end sort values. You can see all the missing value will be, but it will sort every meaningful stuff, but all the missing value will be at the end. Yeah, so any question? Okay, you can also sort the data based on a particular column. So let's look at an example. This is our data frame BA, right? So now maybe I can sort my data by a particular column. So you can see sort by value, but you provide the column you want to sort by. So this means that here you can see 0, 1, 2, 3, but I want to sort the data based on this column. So when I run this guy, then meaning that it will sort based on this only column. You can see that it sort the column. It start from the minus the smallest and increasing. So, but you can see here, since it start sort by this, it means this will change. Therefore, the index, can you see that? -3, 2, can you see 2 in the index is 3? Can you see the data changes? So also this one will automatically change A because you index by this guy. Yeah, so because the 2 is already 0, that is why it looks the same. The 3 is 1, that is why. So we just change this one, and because it's the same, that is why you may see that A is not changed, but it typically change. But you can sort by multiple columns. So we can say if we want to sort by A and B again, we can put them as a list. So let's look at the difference here. You can see here we sort by 2. You can see here the previous one we sort only by B, we can have 0, but here we want to sort by A and B. It means 0, 0. So you can see the lowest one is -3 and 0, then the lowest one 4. I mean, the sorting here is 4 and 0, right? Yeah, so that's what happened when you want to sort by multiple stuff. Yeah, do we have more time? Okay, we have 9 minutes. So the discuss something duplicate levels. When we have, for example, our data frame here, we can use index is unique to see if actually our index are unique. But if our index are unique, we can do some stuff. So now when you try to slice something data frame or series with index that is not unique, this will not give us a single data, but we have multiple A's, it will return the A's, multiple A's. Yeah, if we try to index C, we can see because C we have only one, it will give us only one value. There's some old logic also apply to data frame. If you want to do the selection, if we have a data frame here, we can see we have BB, right? So when I want to log slice B, I have B, it will give me multiple B's, right? So this is something we should know. Finally, summarizing data. This is very useful in Pandas. Pandas is very useful in summarizing the statistics. So what we mean by this is that we can see here that we have a data frame. Can you see that? A data frame here with this. Now, we can use what we call summaries, which are basically some statistical functions. So sum will try to find the sum of, let's look at it. So sum, we call data frame the sum. Sum will try to find the sum of this column. Can you see that? And sum in this column. So this is a sum function. We can actually pass axes if you want to sum along the columns, which will also do the same thing, what we have seen here, which is sum. So it will basically do the that along the axis. We also have aggregation functions that can do mean. So given a data frame, you can call a mean that can calculate the mean of our data frame. So this is something you should know. All these functions, they are available. We have also describe method in Pandas. So given our data frame, this is a statistical function that can find the statistic of your data, some statistics. So we have our df here. This is our data frame. So this is our data frame. This is a function called describe. What it does basically, it try to find the statistic. So the count in each, the 1 and 2, it will say that, okay, what is the mean? What is the standard deviation of this data? What is the minimum of this column data? So because we have this, right? We have this count. I mean, how many data points we have? We have 1, 2, 3. Here we have 1, 2 because we have NA. That's its count. Mean standard deviation of this data. The mean, this is described. It's a statistical. You remember when we are doing the machine learning, we use this method function describe to describe the data. But when numeric data, when you have numeric data, because you can see here, this is some stuff. When you have numeric data, let's show what we mean by numeric data. I have this guy. So you can see here, we have numeric data, right? Right. So when we call this, the method will change and give us different kind of calculation. So you can see here we have count. It doesn't give us this stuff, right? Because here we have categorical 1, 2, and so on. So here we have count, unique, number of unique, top is a frequency. So the describe method works in 2 different ways. If it is numeric data, if it is numeric data, it will return this kind of statistic. But if it is non-numeric data, it will return this kind of statistic. All right, so I think we come to the end of the chapter. We discussed a lot. This is just Pandas. We will see now here we build the intuition on how some of the functions, some of the stuff in Pandas. The next chapter, what we'll be seeing is let me use this and show us this. Can you see the book? Can you see the book? Hello?
Yes, yeah.
Okay.
We can see.
So you can see here what we finished is this Pandas data chapter. Please go through this Pandas. I think we will try to do some exercise to nail this concept so that as a practice, because the only way you can remember this stuff is through practice. So we will go through some practice. I will share them so that we can see how this stuff works. So the next thing we will see is to use, now we understand NumPy and Pandas, right? Now we will use this knowledge of NumPy and Pandas to do data analysis. Right. So now we use this knowledge to Pandas. You can see how we can read the data, all this stuff. We come and now do them. The moment we come, we will see that, for example, this read CSV and all other stuff. Yeah, so that's what we do next to try to understand how we can use this kind of structure to do some kind of data analysis. So tomorrow, inshallah, we'll start going through this chapter, data loading, storage, and file format. Yeah, we are halfway now, I think, since we do chapter 1 through 5. Yep. Any question before we go? Yep. Any question? Okay.
Doctor, it is regarding the files that I've shared with you.
Okay. Yeah, we can hear magana after.
Okay, to share okay.
Okay, right. So I think we see tomorrow, inshallah, and continue from this chapter. You can read the chapter, and anything that is hazy is not well explained. I hope it will be clear when you we just introduce and go through it. Yeah. Right. Any question? Okay. So I think if there's no question, I think we can meet tomorrow. Yeah. Bye everyone. Yeah, Zaradin me kake cewa ni kai? Yeah, okay, ka turo min da wani file ko?
Okay, wannan wani issue da muke samu na kamar data ce ta zama kamar heterogeneous. Abin da haka data set din ce take dan bayan mu issue. Shi ne na ce ban sani ba, na yi trying dai, na yi trying possible, ina kokarin na canja abin nan data types din. At long run, object volume ne ya zo a data set din na stock exchange, ya zo as object, so na yi converting ɗinsa to plot. So the remaining features, they are of type integer. Okay. So for that, I have to convert them to plot. So the issue, the problem in the nake samu is out of the remaining features, target dinner is plot 32. The remaining features, they are also plot 32, but one of them is plot 64. So if I try to run my models, I have built my models so that I was unable to test it.
Okay, so
saboda wannan issue na data, na try method da yawa, shine dai nace ban sani ba.
Okay, so kake ka canja data frame, so kake ka canja data type din from to zama the same data type?
Duka sama yawa, saboda ai zaka ga idan nayi running na duka models din da ne, da na SBR da shi MLP, kowanne ya sai ya bada wannan error, saboda wannan an samu issue na wayannan dukan su target is 32.
So how do you do? What do you do? How do you change? We know how do you change in i.e. do you use Pands to change the data type or what?
Yeah, I have used Pands. Now using different method na type casting. Na type casting na su the data types.
Okay.
Za ga ni a ciki din nayi aiki.
So zan bude gani na bude a
okay, to za ka gani yawa to shikenan.
So lokacin sallah, yes. Okay. So see you tomorrow, inshallah. Bye all.